Thank you. Thank you, and good morning. I am Harley Stoddart, and I do work for the Agriculture and Horticulture Development Board, which is a UK levy board for agriculture. We cover beef, sheep, lamb, pigs, potatoes, horticulture, and cereals and oilseeds. We're not a government agency, and we don't deliver government policy. But we are an evidence-based organisation, and we do inform into policy making. Our total annual income is about 63 million euros, or about 550 million krona. A couple of definitions to start with. I get the lucky job of talking about land use change. It's really simple. But essentially, land use change is changing the use of land from one thing to another. Cutting down forests, building houses, land use change. Changing from food production to non-food production. Changing from food production to houses. Any which use is land use change. Indirect land use change, slightly trickier. This is the knock-on effect. This is the theoretical unintended consequence of releasing more carbon, more greenhouse gases than intended due to the expansion, predominantly, of croplands. And biomass, the bioeconomy, largely driven by the demand to see reduced greenhouse gas emissions. So that unintended consequence, indirect land use change, is really rather important. And it probably presents the greatest impediment to accurately calculating the GHG emissions of any land use. And policy has been, there are plenty of people in the world, there's plenty of groups looking at working on calculating and modelling indirect land use change, predominantly for policy direction. Which way should we go? How should we handle it? One of the things that isn't always calculated into these models is something along the lines of co-product allocation. Now this is basically, if you're using wheat to produce bioethanol, you're also producing a high-protein animal feed. And where the co-product allocation is factored in, it's often done on the basis of energy, because that's what the European Commission's Renewable Energy Directive says. Do it on energy. But the nutritional value of the high-protein animal feed, the nutritional value is in the protein, not the energy. And the protein is displacing those soy imports from South America. And actually, if you look at protein displacement as a co-product allocation, the GHG emission savings actually gets better. This whole area is still evolving. The modelers are still modeling. The modelers are not at fault. The modelers are told on what basis to model and on what basis to adjust the co-product allocation. But my point is that we are already good at growing crops. We do this very well. And we're quite good at utilising them as well. We're already producing crops and their co-products, which are low or zero indirect land use change feedstocks. And just to reiterate, the high-value protein into animal feed is displacing other animal feed crops and reducing the demand for crop area for animal feed and displacing soy, just in case you didn't get that. Another example, and I use William Craycroft Ely. He's not particularly special. He just happens to be a farmer in the east of England. And some years ago, he took out 10% of his arable area and put it down to an energy crop. He put it down to miscanthus. From his point of view, it was a bit of an experiment, see what happened. And what happened was, because he took out the corners, the difficult to reach bits of his land, the awkward bits, the difficult bits, he actually ended up increasing his productivity of the other 90%. So whilst he took out 10% of his land, his arable productivity over the whole farm only dropped by 2%. Taking out 10% should have huge direct and indirect land use changes. But with only dropping 2%, that's much, much less. And he still had the miscanthus. He still had the energy crop to utilise. What's more, he also had resource use efficiency increases as well, because he was using his machinery more. He was using his storage more, because you harvest miscanthus at a different time as to when you harvest your cereals or oilseeds. This is a good example of indirect land use change mitigation. It's difficult to say what the future is going to hold. Will it have better models? Almost certainly. Modeling is inherently very complicated. There are a large number of parameters, a requirement for vast amounts of data, and an awful lot of assumptions. Some of those uncertainties will become more certain. The models will get better. But I come back to the point that we can already produce low or zero indirect land use change biomass. And we are already able to demonstrate mitigation as well. These are things that we can already do. I want to make a further point with regards to biomass. There's a lot of policy direction at the moment which is moving away from food. Food is sacrosanct. Fair enough. We have to source our biomass responsibly, and it shouldn't be at the expense of food production. But we grow crops well. And things like sugar and sugar beet are amazing platforms to take through to chemicals or to fuels or to all sorts of things. And they shouldn't be dismissed out of hand, particularly where you can demonstrate increased yields or other mitigations which deliver low or zero indirect land use change biomass. So my conclusions. Indirect land use change modelling at the moment is at best a best guess. It's also being developed in order to produce ILUC factors to influence policy direction. I would say that actually if you take that modelling and instead of using it to further policy and develop ILUC factors, and you use that modelling to allow people to deliver through supply chains, through assurance schemes, in the low or zero indirect land use change biomass, and mitigate for that indirect land use change. This is already happening, it is already possible, and it can go an awful lot further. But as sure as eggs is eggs, never really understood that. As long as there is policy uncertainty, there will be a lack of investor confidence. And without that requisite investor confidence, we will not have the industrial infrastructure in order to deliver the fossil substitutes, the GHG savings, and the environmental protection. And environmental protection, GHG savings, and fossil substitution is actually exactly what those policies will put in place to deliver. I want to leave you with one last thought. I've become a big fan of a man called George Box. Unfortunately, he died last year. He was 95. He was a statistician. So statistically, 95 is not a bad innings. And he had this to say. Essentially, all models are wrong, but some are useful. And the practical question is, how wrong do they have to be to no longer be useful? Tack.